In this video, I'm going to show you how to solve the ALEKS problem called calculating enthalpy of vaporization from vapor pressure. So this problem is going to give us 3 sets of temperature and vapor pressure data, and we're asked to use that to calculate the enthalpy of vaporization. The relationship between these 3 variables is kind of linear. If we take the natural log of the pressure and plot it against 1 over the temperature, then the slope of the line that we get is going to be equal to negative delta H over R. R is our constant, 8.3145 joules per mole Kelvin. So if we know the value of the slope of the line and obviously we know the value of R, we'll be able to figure out delta H. So I don't want to make it sound easy because it's not quite that easy. The process is relatively simple, but actually executing it is pretty tricky. So before we can, or I guess our first step, number 1 step, is to figure out what the slope is. But before we can figure out the slope, notice that we do have to do some converting of our data. So we've been given the vapor pressure. We actually need to know the natural log of the vapor pressure. We've been given the temperature. We need to know 1 over the temperature. In addition to that, there needs to be a little bit of unit conversion as well. When we calculate the natural log of pressure, the pressure needs to be in units of atmospheres, and that is actually what we have, so that's good. When we do the 1 over T calculation, that temperature needs to be in units of Kelvin, and that is not what we have. Our temperature is given to us in degrees C. So we're going to need to convert our temperature into Kelvin, and then we can calculate 1 over temperature. We also need to calculate the natural log of our vapor pressure. So let's just go ahead and do those calculations. I'm going to start by converting my temperature into units of Kelvin, and while I'm doing that, I'm also going to do my 1 over T calculation. And then after I do that, we're going to calculate our natural log of pressure. And I'm just going to be leaving units off of all of these numbers. So for our temperature, 273.15 minus 14, our first temperature is 259.15, and you don't even need to be writing these numbers down actually, because the number that we actually need is the 1 over T. So that is 0.00385 9. I'm going to go with 4 sig figs, and I'm going to move that over. 4 sig figs, actually looking at ALEKS is using 6 sig figs, woo, for those 1 over T. So I better add some sig figs to this number so that I don't get it wrong. 385877. Okay, our next temperature is negative 5, 273.15. 273.15 minus 5 is 268.15, and we actually need the inverse of that. 6 sig figs, 0.003729226. And then last but not least, our final temperature is 4, 273.15 plus 4 is 277.15. The inverse of that temperature to 6 significant figures is 0.00360815. Now for our next set of data, our pressure data, this one's going to be a little bit easier. We just need to know the natural log of all 3 of these pressures. The first pressure is 0.207. The natural log of that, we're going to go with 6 sig figs again, negative 1.57504. And our next pressure is 0.276. The natural log of 0.276 is negative 1.28735. And then last but not least, the natural log of 0.362. That is negative 1.01611. Now, if you have a graphing calculator, or if you want to use something like Excel to plug this data in and have it calculate the slope for you, then that's cool. Go ahead and do that. If you don't, then I'm going to show you how to just kind of quickly get the slope calculated for this particular line. What we're going to do, I'm actually going to erase this portion just for a second. The slope is going to be calculated by taking your smallest value of the natural log of pressure, and from that subtracting your biggest value of the natural log of pressure. Remember that slope is the rise over the run, so we need to know the largest and the smallest natural log of pressure. We need to know that value. We're going to take the smallest natural log of the pressure and subtract from that the biggest. Now be careful because these are going to be negative numbers. So the smallest natural log of my pressure is not this number because these are negative numbers. This is my smallest natural log of the pressure because it is the most negative. And then underneath that on the denominator, we are going to take our biggest value of 1 over t, and from that we are going to subtract our smallest value of 1 over t. So for my data, my smallest natural log of pressure is this number, and my largest natural log of pressure is this number right here. And so that is going to be negative 1.57504 minus negative 1.01611. And I'm going to divide that by my largest temperature, which is this first one, and my smallest temperature, which is this one. My largest temperature is 0.00385877 minus 0.00360, totally running out of room, 815. And I'm going to use my calculator to calculate the value of that slope, 1.57504 minus a negative 1.01611. And that I'm going to divide by 0.00385877 minus 0.00360815. This is a really brutal ALEKS problem. There are so many spots where you could just copy the wrong number down and then you are in trouble because you're going to get the problem wrong. So this is my value of slope, and it ends up having units of Kelvin. These natural log of pressures are unitless numbers, so these numbers here have no units at all. My temperature unit is 1 over Kelvin, so when I divide 1 over Kelvin, the answer that I end up getting just has units of Kelvin in it. And what I'm going to do is, let's see, where can I fit this? I'm going to take that slope. Remember earlier I said that the slope was equal to the negative delta H over R. And let's not forget, what is the point of this problem? We've done so much math, I've forgotten what we're trying to do. We're trying to calculate the value of delta H. So we're going to use some algebra, and we're going to say the slope, which we just calculated, times R is going to be equal to negative delta H. And let's multiply both sides of this math problem by -1 so that right-hand side turns positive, and we'll make the left-hand side negative, and I'm just going to get rid of that plus sign. So if we take the negative slope multiplied by R, that's going to give us our delta H value. Our slope is negative 2230.19 Kelvin, and the value of R that we're using is 8.3145 joules per mole Kelvin. Now those Kelvin units are going to cancel out. See that? So we're going to end up with units of joules per mole, which are units that are consistent with delta H values. And I feel, okay, yeah, we're doing good. So I'm going to I'm going to take the negative of my answer, and then I am going to multiply it by 8.3145. And that gives me positive 18,542.9. My units are joules per mole. Now, because that's such a large number, I'm guessing that ALEKS probably wants us to put it in units of kilojoules. Ooh, it actually doesn't say what unit we should be using. I think that it's probably pretty wise to turn this into kilojoules per mole. That's pretty standard for delta H, and it says that it wants it to 2 significant figures. So for my number, I'm going to have 19 kilojoules per mole. Good luck with this problem. It is super complicated, but if you just take your time, make sure you don't make any mistakes with your copying your numbers down, you should have no problems with it.